Welcome, my name is Fabian, and in the following I'm going to talk about how you create a physical design for the horizon block and pod architecture. When we look back at the design methodology that we followed through all of our horizon projects, we have defined the use cases, the service definition, we've created our conceptual design, we've created a logical design. Now we need to apply those information into the physical design. The physical design includes all kind of concrete configuration parameters, IP addresses, VLANs, the sizing of the server, probably the placement of certain components. Now we really need to give a pure definition, a concrete definition of how the system looks like. So, for sure, during this video session, we're not able to go through all of those single configuration elements, but we try to give you some kind of guideline, which components are important, which design characteristics on a physical level might impact the solution in the end. Yeah, from a logical design perspective, we apply this horizon pod and block architecture. What does it mean? We have a management block that contains all kind of management components, vCenter server, connection server, probably components like the VMware Unified Access Gateway, App Volumes Manager, databases, domain controller. So what we need to define now in the physical design phase is where do we place physically the components of the management block. That's one very important thing. At the same time, we need to configure, we need to define the single configuration items of all the elements in the management block. When we talk about the resource block, we have figured out that the resource block handles up to 2,000 sessions typically, but it really depends on the use case. If we have heavy workload requirements, heavy, kind of certain characteristics or special connectivity criteria, we might reduce the number for certain resource blocks in our environment. So the maximum is 2,000 sessions per resource block, and in the physical design phase, we need to align this resource block to the physical vSphere cluster, to the physical servers we have underneath, to our environment. When we talk about certain global settings of our horizon pod, we need to define those global elements that we configure in the horizon admin. So what we need to do is we need to discuss those configuration items and compare them to any kind of requirements. Do we have any kind of security requirements that need to be changed? Do we have any kind of specific desktop requirements where we need to do some global changes on our connection servers? So for example, the session timeout is by default 720 minutes, which means if we have any kind of security compliance dependency, some compliance guideline, we need to probably reduce this number globally. Or what should happen if any kind of interrupt appears in the connectivity? Does the user need to authenticate again or not? Another important topic here is, do we want to use Windows servers as a virtual desktop? That works, that makes sense in certain way for licensing reason. If you want to use Windows servers that are licensed per CPU, per core, to use them as a virtual desktop. That's what we can configure in the global settings to allow those Windows servers to be used as a virtual desktop. What else can we define? We can define pre-login messages. If we want to do some maintenance on the weekend, we can probably add some information for the end user that he sees, okay, there is some maintenance going on. I need to save all of my data, or to give him some kind of a welcome screen where he sees, okay, that's how I reach the help desk, that's how I get to the internal wiki to get further information about the area where the user is now working on. And for sure, if we do some maintenance, we might be able to force the user to be logged off, and we can define globally if there is any kind of a warning messaged or displayed when this log off will be forced by the operations team. Besides those global settings that we need to consider in our physical design, we also need to size our environment properly. And if we talk about the vCenter server, in our Horizon block pod architecture, we typically have one vCenter server instance for a resource block, and we have one vCenter server for our management block, which means now, depending on how many resource blocks I have, the more vCenter server I need. Typically, we say for link clones, we take only around 2,000 link clones per vCenter server as a limit. And for sure, we then need to decide how this vCenter server must be sized. Must it be sized in a small way, in a large way? We will talk more about that when we talk about the physical design or the physical vSphere design of our Horizon environment. But typically we see something like for 2,000 sessions we need 24 gigabyte of memory and around 8 vCPUs to give the vCenter the resources it needs to interact in a proper way with the Horizon environment. When we talk about the connection server, we need to understand that we have in the connection server binaries 4 different types of connection server. The standard connection server is always the first connection server that I install in a Horizon pod. Okay, so one Horizon pod or one Horizon instance always starts with a standard connection server. If we now want to scale out our environment, if we now want to create high availability or a higher number of supported sessions, we install multiple replicas into our environment. We support up to 6 replica server and 1 standard server in the environment, which makes a total of 7 connection servers in our pod. Another functionality of the connection server is the so-called security server. The security server is a Windows-based component that can be placed in the DMZ and allows secure access over an unsecure network like the internet to our virtual desktops. The security server kind of offers the same functionality as the newer and modern approach of the Unified Access Gateway. Even though we prefer the Unified Access Gateway, the security server is still in place and might be suitable in certain scenarios. Last but not least, we have the enrollment server. Last but not least, we have the enrollment server as a connection server role that we can install. The enrollment server is used for true SSO functionality. So it integrates with a CA infrastructure of the customer. It offers us the opportunity to use single sign-on mechanisms of our mobile device to use that directly to enter our virtual desktops or virtual applications. When we talk about the connection server itself, we need to know which services are installed on the Windows machine where the connection server role is installed. And those services for sure differ depending on the component that I install, but we need to know that those services are there, that services like the connection server service must be started, that the Horizon pod is really functional. We need to integrate those services in some kind of monitoring solution to make sure our service availability is granted. Make sure that the RPC service of Microsoft Windows is also running, since we use the ADLDS database within all of our connection server and the replicas. We need to make sure that the replication mechanism works properly between those connection servers And that's why we need to make sure that the RPC service of Windows is running as well. As we said before, we need to determine how many connection servers we will need in our Horizon pod architecture. And that typically depends on two things: the number of connections we need to fulfill in our design, and probably the way users are accessing their environment. When we install connection servers, we need to make some design decisions. We need to make a design decision if connections between the endpoints, so our smartphone, our physical laptop, to the virtual desktop is either tunneled or direct. So if it's tunneled, it always goes the connection flow over the connection server and then to the virtual desktop, which for sure kind of simplifies the way firewalls, network characteristics are applied. But at the same time, we create some kind of dependency from the connection server, from the availability of the connection server. So typically, a direct connection is used in an internal construct of the corporate LAN, for example. And as soon as we come from the outer world, from any kind of non-really defined network construct, we typically use the tunnel connection right here. For direct connections, we by default support 2000 connections that can be adjusted to 4000 in newer versions of Horizon. If we have a tunnel connections, we are limited to the 2000 limit here. Again, we scale out our connection servers for the reason of connections capabilities and redundancy for failover scenarios. So if we want to increase the availability, we add multiple connection server and replicas to our pod, and we need to make sure that we cannot reach the maximum of 7 connection servers in our Horizon pod. That is based due to a limitation of the Java message service in our environment. The Java message service is used to exchange quick information between the connection server. Typically on a connection server, we have our AD-LDS database with a persistent storage and data set. But in certain scenarios, the slow replication time of our AD-LDS is not quick enough to exchange specific connection-based information, which connection server is allocating which connection slot to a certain virtual machine. Those information are exchanged via JMS. And JMS has some limitations regarding latency. That's why we place all the connection servers in one site. And it has some limitation regarding scalability. That's why we can only have a maximum of 7 connection servers in our pod, while we always recommend to do 5 active connection servers and 2 are there as a standby component in case that a failure occurs. When we talk about specific connection server settings, we talked about global settings of Horizon before, and now we talk about specific settings that needs to be done for every connection server. Every connection server can be configured with so-called tags. We talked about that before. A tag allows us to differentiate between internal and external access. We can create desktop pools with an internal tag that only connection servers with an internal tag are allowed to make a connection to. So that's where we can align or apply some security policies right here. At the same time, we need to specify the gateway and external addresses and IPs, how the Horizon pod or the connection servers are reached from the end user. If we talk about a connection server where we have typically placed a load balancer in front of it, we need to specify the load balancer's FQDN and the load balancer IP address for our HTTPS secure gateway, for our BLAST secure gateway, for the PC over IP gateway. Make sure to design that properly and to understand how the connection flow between the end user to the virtual desktop works. We will talk more about that in a section when we talk about the network physical design. Another element that's really important to consider is how does the authentication takes place within our environment. We can configure the connection server in a way that the connection server itself is responsible for doing the authentication. Since the connection server is joined to the Active Directory, it can verify the credentials that were typed in by the user and can allow or disallow an access. What we can also do is to enable SAML. The secure assertion markup language is typically used in any kind of single sign-on solution, like we have it with Workspace ONE Identity Manager. So what we can do is that not the connection server is responsible for the authentication method, it just kind of redirects the authentication to an identity provider, to the identity manager. That returns a proper SAML token to the connection server that then, or to the user over the connection server, that then allows a proper access or not. We have multiple options what we can configure here. We probably don't want to allow SAML authentication at all. We can enable SAML authentication, and we can make it either required or optional allowed. Okay, so optional allowed means you can either authenticate via the connection server or the SAML authentication, or you must go over any kind of third-party SAML authentication product like Identity Manager. When we talk about the sizing of the connection server, that's also a very important point. We've figured out based on the connection based on the size, on the availability requirements, how many connection servers we need. We now need to also understand how we size our connection servers. And typically, to be able to handle the maximum load of 2000 sessions, we should always place 10 GB of memory into the connection server and 4 vCPUs. Well, once we have this configuration, the internal Java processes are probably configured, and we can make use of the maximum number of sessions in our environment.